Thank you once again for tuning in for us to continue solving the other WASSCE Further Mathematics Paper 2 from where we left off. So WASSCE 2023 Further Mathematics Paper 2. We are continuing from question number 9 through 16. So if you are looking for the questions 1 to 8, you can check the previous video that we uploaded on this channel. So to begin, let's just proceed to the question number 9. It says a committee of 5 people is to be chosen from 6 midfielders, 3 attackers, and 7 referees. If each discipline must be represented, determine the number of ways of selecting the committee to include exactly 1 midfielder and 1 attacker, exactly 2 midfielders, at least 2 midfielders. So let's begin with the first one, exactly 1 midfielder and 1 attacker. So we have exactly 1 midfielder to choose from 6. We have 6 combination, one way of doing that. So choose 1 from 6. It means 6 choose 1. 6 combination 1. Then we have exactly 1 attacker. So we have 3 choose 1. So we choose 1 from 3. Then we are left with the other 3 people because it says 5 people. So 1 plus 1 is 2. So we are left with 3. We can choose them from the referees. So 7 choose 3. Choose 3 from 7. So that will give us 6 times 3 times 35, which is 630 ways of doing that. So this is the A part. Now let's look at the B part. This time exactly 2 midfielders. So exactly 2. We have this case, this possibility that when we choose exactly 2, we have to choose 1 attacker and 1 referee. Again, when we choose exactly 2 midfielder, we have to choose 2 attackers or 1 referee. So we are left with this number of ways, 945 plus 315, and that will give us 1260 ways. Then at least 2 midfielders. At least 2 midfielders. So that one too, we have exactly 2 and exactly 3. We can't go to exactly 4 because it must represent each discipline must be represented. So we can't go to exactly 4 because when you go to 4, you can get 401 or 410. But in that case, it means we are leaving out one of the disciplines. So we have only one possibility for exactly 3. 311. So we have 3. So 6 choose 3. 3 choose 1. 7 choose 1. So that will give us 420 ways. We add it to the previous possibility of exactly 2, and that will give us 1680 ways. Okay, so let's move on to number 10. We have to solve this question. It's not very clear. This one is looking like 4, at the same time it's looking like 1. So I'm going to solve one of them. I'm going to solve this one. Then please, I'll play with you to try this one. It's follow the same pattern. You get similar answers. So I'm going to solve the second one. We are solving 1 over 4 exponent y plus 1 all over 3 minus 5 into half exponent y plus 1 all over 3 plus 4 equals 0. So what we are going to do is that we are going to make use of this this property of indices. A exponent m n is the same as A exponent m all exponent n. So in this case, this is my n. Oh, okay. So first of all, I have to rewrite the 1 over 2 as 1 over 4 as 1 over 2 all squared before I make use of this property. So the 1 over 2, so the 2 here will come and multiply the exponent which is already there which is 2 times y plus 1 over 3. So now make use of this property. So using that property, then the 2 will come and erase everything. So this is like my n. The m and n can swap, it doesn't matter. You can also write it as 1 over 2 exponent 2 all exponent y plus 1 over 3. But that will not give us the same thing appearing here. So that is why we have to rather send the 2 there, so that what is here will be the same as what is here. Then we can do a substitution now. So we let x to be equal to what is showing that is the same in both terms. So if x equal to that thing, then we have that thing squared minus 5 of that thing plus 4 equals 0. So if that is the case, then it has become a quadratic equation in x, which can easily be factored. So factors of 4 that when we add we get negative 5 is negative 1 and negative 4. So we have to factor it, x minus 1, x plus x minus 4 equals 0. So either we have x equal 1 or x equal 4. So in that case, it means we are doing back substitution. This is x, so we put it there. So this thing is equal to 1 or is equal to 4. We have to write 1 and 4 as a number with a base half because of this, to a certain exponent. So we know that half exponent 0 is 1. So we put it there. This will give us 1. Then also half exponent negative 2 is also 4. Now we are there. We can now equate the exponent. So if that is the case, we will have y plus 1 all over 3 equals 0, or y plus 1 all over 3 is equal to negative 2. That will give us either y equal negative 1 or negative 7. We need to check if our solution is correct, or if this will satisfy all the equation. If this will satisfy the equation, but you realize that negative 7 will not satisfy it, but negative 1 will satisfy. You can try it. You put negative 1 here, you get 0 here. And when you put negative 7, we don't get 0, which means that the only solution is y equal negative 1. Good. Now it proceeds to the B part of the question. If alpha and beta are the roots of x squared plus kx plus 11 equals 0, and alpha squared plus beta squared equals 27, find the possible values of k. So we know that alpha plus beta, so this is the equation given to us. Alpha plus beta is minus b over a. The b is k and the a is 1, the coefficient of x squared. So this will give us alpha plus beta equal negative k. Then again, alpha beta is equal to c over a, which is 11 over 1, and that will give us 11. Now we're given this equation that alpha squared plus beta squared equals 27. So what do? We know alpha squared plus beta squared is the same as alpha plus beta all squared minus 2 alpha beta equal 27. So if that is the case, we can substitute alpha plus beta, which is negative k, then alpha beta, which is 11, equal 27. Now we get 22 plus 27, which is 49. So k is equal to plus or minus square root of 49. That will give us negative 7 or 7. Now before we proceed, please kindly subscribe to this channel, and also like this video. So you subscribe by clicking here, then you also give it a thumbs up by clicking this, then also please share this video on social media. Share it for me. You can share it on all your social media channels, all your social media platforms. You can copy and paste the link. Thank you for doing so. And also always check this position for more videos. Thank you. So question number 11, we have to express 1 minus 8x minus x squared all over x plus 1 into x minus 1 all squared in partial fractions. So partial fractions, we set up the partial fraction like this: a over the first factor, b over the first linear factor, then over the second factor with the repeated factors. So we now have to collect the LCM, and that will give us what we are seeing here. Remember, x plus 1 will come here and cancel this. We're left with x minus 1 square. It will multiply the a. Then x minus 1 will come here, cancel one of these. We're left with x plus 1, x minus 1. That will multiply the b. Then x minus 1 square will come here and cancel this. We're left with x plus 1. That will multiply the c. So if that is the case, then the next thing we are going to do is to equate the numerators. So if the numerators are equal, we can now put values of x to make some of the variables 0. So if x equal 1, this will be 0, then this will also be 0. Then you're left with only this. So we are going to get 1 minus 8 minus 2c. So that will give you negative 8 equal to c. Because this and this will become 0. So c will be equal to negative 4. Then again, when x equal negative 1, this time this one will be 0, and this one will also be 0. So you are left with the a term. So you are going to get positive 8 is equal to 4a. So dividing through by 4, you get a equal to. Then also, when x equals 0, we obtain this equation: 1 equal a minus b plus c. So we know the values of a, b, and c already, so we put them inside and we solve for b. We know the value of a and c, so substitute and solve for b to get b equal negative 3. So it means that this partial fraction is equal to 2 over x plus 1 minus 3 over x minus 1 minus 4 over x minus 1 all squared. Now to the b part of our question. Given that log to base 81 of y is equal to n log 3 of y. So we are supposed to find the value of n. So what are we going to do now? We change base. There are so many ways you can do it. I'm going to change base. So when I change base, I'm going to change the base of these to, I'm going to change the base of these to 81, to base 3. So it becomes log to base 3 of y over log to base 3 of 81 equal n log to base 3 of y. Now we can simplify the log to base 3 of 81, and that will give us 4. Now we divide both sides by n log 3 y. We will divide both sides by log to base 3 of y, and that will give us n to be 1 over 4. Here we have question number 12. A book club sends 4 science fiction and 6 history books to John. He chooses 4 of these books at random to take for vacation. What is the probability that he chooses exactly 2 history books, at least 1 science fiction book, an even number of history books? So exactly 2 history books. It means he chose 2 history books and chose 2 science fiction books. So number of ways to choose 2 from 6 is 6 combination 2. The number of ways to choose 2 from 4 is 4 combination 2, all over 10 combination 4, and that will give us 15 times 6 over 210, which is 3 over 7. Then at least 1 science fiction books. It means that he chose 1 or more science fiction book. So when he choose 1 science fiction book, then he will choose 3 of the history books. When he choose 2 science fiction books, then you can choose 2 because it's choosing 4. Then when you choose 1 science fiction book, then you can also choose 3 of the. If you choose 3 science fiction books, you can choose 1 of the history books. Then you choose all 4, then it means you choose none of the fiction books. So all over the total, which is 10 combination 4, and that will give us 195 over 210, which is 13 over 14. Then we have the C, an even number of history books. So even number of history books, you can choose 2, you can choose 4. So choosing 2, exactly 2 or exactly 4 will give us this result, and that will give us 105 over 210, which is the same as 1 over 2. So here we have question number 13. The table shows the height in centimeters of plants in a garden. We have the height 51 to 55 up to 76 to 80. We have the frequency. Using 65 centimeters as an assumed mean, calculate correct to 1 decimal place the mean height, the variance, standard deviation of plant in a garden. So we can quickly form this table. We have the interval, then the midpoint. Midpoint, add 55 and 51, divide by 2, we get 53. You repeat the same thing to get all of this. After you get this, the distance is 5, so keep adding 5 till you get to the last interval. Then we come to the frequency, then the deviation column, we subtract the x values from the assumed mean, which is 65. So 65 minus 53 is negative 12. 65 minus 58 is negative 7, and so on up to 65. Sorry, 53 minus a, which is 65, then 58 minus 65, 78 minus 65 will give you this. So that is how you get your deviations. Subtract the assumed mean from the x values. Then when you come to the FD, you times these values by the frequency. So 3 times negative 12 is negative 36. 10 times 8 is 80. 2 times 13 is 26. Then FD squared, you multiply this column by this column. That will give you these values. So after that, you sum up everything. Then you can now calculate the mean height. Mean is given by assume mean plus summation FD over summation F. Summation FD is 35. Summation F is 50. So mean will be equal to 65.7 centimeters, not meters. Then we are supposed to calculate the variance. The variance is given by this summation FD squared over summation F minus summation FD over summation FD all square. So we substitute the values, then you get 39.2 centimeters. 29.2. Variance has no unit because just calculating the how spread this thing is. Then we also have the standard deviation is the square root of the variance. So that will give us 6.26 to 1 decimal place we have 6.3. Question number 14. The vectors m, n, and r relative to the origin are given by position vector OM equal I minus 2j, position vector ON equal 3i plus 2j, and position vector OR equal negative I minus 2j. We have to find correct 1 decimal place angle M and R. and find correct to 3 significant figures, the perimeter of triangle MNR. So we can illustrate it in a diagram like this. Position vectors ON, OM, then OR. So we can connect the vertices to get that we are finding angle MNR, this angle here. So we use a dot product. Remember that the dot product vector NR or vector NM dot vector NR will be equal to absolute value of their magnitude, then cosine of the angle between them. So we need to find vector NR, which is OR minus ON. Then we substitute the IJ values, and that will give us vector NR to be negative 4I minus 4J. And similarly, vector NM will be vector OM minus ON. So when you simplify this, we also get negative 2I minus 4J. Then again, position vector. Okay, so now we substitute the values into this equation here. So we dot the two vectors, we multiply negative 4 by negative 2, that will give us 8, plus 4 times 4, that will give you 16. Then find the distance, the magnitude of the vectors. So magnitude of vector AI plus BJ, magnitude is square root of A squared plus B squared. So that is what we are doing. So the A here is negative 4, B is negative 4. And the same thing, you can see A, you can see B. So we substitute them into the formula, we get that. That will give us 24 equal 8 root 10 cos of the angle between the two vectors, as we can see. So angle M and R we equal to cos inverse of root 10 over 5. When you simplify this, you get root 10 over 5. And that will give us 18.4 degrees to 1 decimal place. That is the angle between the two vectors. Now we are going to look for the perimeter of the triangle MNR. So already, since we've calculated the vector NR, you don't have to waste our time there. We use it. The only thing you have to do is to calculate position vector. You have to calculate vector MR using position vector OR and OM. So that will give us negative 2I plus OJ plus 0J. So the perimeter is the magnitude of all these vectors. So when we add them, we get 12.13. Now, question number 15. Okay, to 3 significant figures, we have 12.1 units. Now to question number 15. An object is pulled up a smooth plane inclined at an angle of 45 degrees to the horizontal. If the plane is 25 meters long and the object comes to rest at the top, find correct to 2 decimal places the initial speed of the object, the time taken to reach the top. So we have this information. We have v equals 0, which is the final velocity, because it says it comes to rest. Then we also have s to be equal to 25. Now we need to get acceleration of this retarding force, which is given by acceleration along this plane is given by g sine theta. So in actual fact, it's a retardation because it is acting downwards, the downwards force. So the acceleration due to gravity will be -10. Substitute into this formula, we get A equal -5√3 meters per second square. So the retardation is 5√3, 5√2 meters per second square. Good. So if that is the case, we can now use this formula V square equal U square plus 2AS. That will give us the substitutions, and when we make U the subject, we get U to be square root of this, which is 18.80 to 2 decimal place meters per second. Now we can calculate the time taken using this formula. V equal U plus AT. So we substitute and solve for T, 2.66 seconds. Now the B part, a particle moving in a straight line is such that its distance is covered in meters from a fixed point, or after time t seconds, is given by s equal 2/3t cubed minus 8t cubed plus 14t plus 5. We have to find the time when the particle is at rest. We know when the particle is at rest, the velocity will be equal to 0. So this is the displacement. So when we differentiate displacement, we get velocity. So the s dt will give us the velocity, which is 2t squared minus 16t plus 14. So this must be equal to 0. We divide through by 2. We factorize this. We have t minus 1, t minus 7 equals 0. So the times that the particle is at rest is at time equal 1 second or 7 seconds. Please don't forget to share this video. Thank you. See you in the next video.